Unit exercise 2. Sum number 1. Prove that n square minus n is divisible by 2 for every positive integer n. So we have to prove n square minus n is divisible by 2, where n is an integer. Now this n square minus n, we can take n common, is equal to n into n minus 1. If n is odd, then n minus 1 will be even, because n minus 1 is 1 less than n. So this n minus 1 will be even. If n is odd, then n minus 1 is even. If n is even, then n minus 1 is odd. In either case, one of the factors of n square minus n is even. Of these two factors, one of the factors is even. That means n squared minus n is divisible by 2. A little. Any integer can be taken as 2k or 2k plus 1. Any integer can be even or odd. If it is even, we can take it as 2k. If it is odd, we can take it as 2k plus 1. So any integer can be taken as 2k or 2k plus 1. Case 1. Let us take the integer as 2k. N equal to 2k. Then n square minus n is equal to n squared minus n is given in the problem. N squared minus n equal to n, we have taken 2k. So 2k whole square minus n is 2k. That is 4k square minus 2k. We can take 2 common. So 2 into 2k square minus k. K is an integer. Therefore 2k squared minus k will also be an integer, some integer. So this can be taken as 2 into m, where m is some integer, where m is an integer. That shows n squared minus n is divisible by 2. Now let us take up the second case. The integer can also be taken as 2k plus 1. N square minus n. Now n is 2k plus 1. So 2k plus 1 whole squared minus 2k plus 1. A plus b whole squared, expand. 2k whole squared, that is 4k squared, plus 1 squared, 1. 2 times 2k into 1, that is 4k. Minus 2k minus 1, that is 4k square plus 2k. This plus 1 will get cancelled with minus 1. We can take 2 common. So 2 into 2k square plus k. K is an integer. Therefore 2k square plus k will again be an integer. So that can be taken as 2m, where m is an integer. That shows n squared minus n is a multiple of 2. That is divisible by 2. In the second case also. In either case, n squared minus n is divisible by 2. So that finishes the problem. Question number 2. Unit exercise 2. Question number 2. A milkman has 175 liters of cow's milk and 105 liters of buffalo's milk. He wishes to sell the milk by filling the 2 types of milk in cans of equal capacity. Calculate the following: capacity of a can, number of cans of cow's milk, number of cans of buffalo's milk. Now in this problem we have to find the HCF of 175 and 105. HCF we have to find. Bigger number 175 is divided by the smaller number 105, remainder 70. Now we divide 105 by 70, remainder 35, divide 70 by 35, the remainder is 0. So the last device at 35 is the HCF. So subdivision 1, capacity of can is 35 liter. That is the HCF. Now number of cans of cow's milk is, total cow's milk is 175 liters. So 175 divided by 35. 35 is the capacity of each can. That is 35 by 7, that is 5. So number of cans of cow's milk is 5. Number of cans of buffalo's milk is, buffalo's milk total quantity available is 105. So 105 divided by 35. That is 21 by 7, that is 3. So number of cans of buffalo's milk is 3. So the problem is over. Unit exercise 2, sum number 3. When the positive integers a, b and c are divided by 13, their respective remainders are 9, 7 and 10. Find the remainder when a plus 2b plus 3c is divided by 13. So it is given in the problem that when a is divided by 13, the remainder is 9. So a is congruent to 9 mod 13. It is given when b is divided by 13, the remainder is 7. So b is congruent to 7 mod 13. Also, when c is divided by 13, the remainder is 10. So c is congruent to 10 mod 13. Now we have to consider a plus 2b plus 3c. So we take the first equation as it is. Second equation we multiply by 2. 2b equal to 2b is congruent to 14 mod 13. And the third equation we multiply by 3. So 3c is congruent to 30 mod 13. Now we can simplify the second equation, third equation. We can divide 14 by 13 and take the remainder instead of 14. We can divide 30 by 13 and take the remainder 4 instead of 30. So the equations can be rewritten as a is congruent to 9 mod 13, 2b is congruent to 1 mod 13 and 3c is congruent to 4 mod 13. Now adding a plus 2b plus 3c is congruent to 9 plus 1 plus 4, that is 14 mod 13. When 14 is divided by 13, the remainder is 1. So instead of 14 we can take 1. So a plus 2b plus 3c is congruent to 1 mod 13. That shows when a plus 2b plus 3c is divided by 13, the remainder is 1. So the problem is over. Here we have simplified and then added. Instead we can simply add a plus 2b plus 3c here. We will get 9 plus 14 plus 30, that is 53, and divided by 13, the remainder will be 1. So a plus 2b plus 3c will again be congruent to 1 mod 13. That is, when a plus 2b plus 3c is divided by 13, the remainder is 1. A similar sum has been done in exercise 2.1, fourth sum. There we have done the problem using Euclid's division lemma. This problem also can be done in that way. So this ends the discussion for this problem. Unit exercise 2, sum number 4. Show that 107 is of the form 4q plus 3 for any integer q. Now there is a correction here. It is not for any integer, it is for some integer. So show that 107 is of the form 4q plus 3 for some integer q. Now let us start. Divide 107 by 4. we get quotient 26 and remainder 3. So 107 can be written as 4 into 26 plus 3. That is 4 cube plus 3. So 107 can be written as 4 cube plus 3 for the integer 26. The quotient is 26. The problem is over. Unit exercise 2, sum number 5. If m plus 1th term of an AP is twice the n plus 1th term, then prove that 3m plus 1th term is twice the m plus n plus 1th term. So given tm plus 1 is equal to twice tn plus 1. You have to prove t3m plus 1 is equal to twice tm plus n plus 1. Here we are considering AP. Now what is given? Tm plus 1 is twice tn plus 1. That is m plus 1th term is twice n plus 1th term. What is tm plus 1? A plus md. Here m plus 1, so m. A plus md equal to 2 into, here n plus 1, so n. A plus nd. So a plus md equal to 2a plus 2nd. That is md is equal to a plus 2nd. A, 2a, when this a is brought here, 2a minus a, it becomes a. So md is equal to a plus nd. Let us call it as equation 1. md is equal to a plus 2nd. You take it as equation 1. Now we are interested in t3m plus 1. So let us write it. t3m plus 1 equal to a plus 3md. Here 3m plus 1, it will be 3md. That is a plus 3 into, what is md? It is there in the equation 1. md equal to a plus 2nd. So a plus 3 into, instead of md, a plus 2nd. So it is a plus 3a plus 6nd. That is 4a plus 6nd. We can take 2 common. So 2 into 2a plus 3nd. Now let us take the right hand side of what is to be proved. 2 into tn plus 1. 2 into tm plus n plus 1 is the right hand side of what is to be proved. So 2 times m plus n plus 1 equal to 2 into a plus, since it is here m plus n plus 1, here it will be m plus n. So m plus n d. That is 2 into a plus md plus nd multiplying. That is 2 into a plus, we know the value of md. It is there in equation 1. md is a plus 2nd. So a plus 2nd plus nd. That is 2 into a plus 2nd plus nd. That is 2 into 2a plus 3nd. So the left hand side value we got t3m plus 1. Now we have got 2 into tm plus n plus 1. Both are found to be equal. Left hand side value 2 into 2a plus 3nd. Right hand side value is also 2 into 2a plus 3nd. So left hand side t3m plus 1 is equal to right hand side 2 into tm plus n plus 1. So the problem is done. Unit exercise 2, sum number 6. Find the 12th term from the last term. Find the 12th term from the last term of the AP minus 2, minus 4, minus 6, dot dot dot, minus 100. So we have to find the 12th term not from the beginning, from the end. Now let us write the series in the reverse order. -2, -4, -6, it is in this order. Let us now write the series in the reverse order. What is given is an AP with the common difference -2. That is -2 plus -2 is -4. -4 plus -2 is -6, and so on. So what is given is an AP with the common difference -2. How do you get the succeeding term? By adding -2. How do you get the preceding term? By adding 2. -6 plus 2 is -4. -4 plus 2 is -2. So to get the succeeding term, we have to add -2. To get the preceding term, we have to add 2. -6. What's the preceding term? -6 plus 2. That is -4. What is the preceding term? -4 plus 2. That is -2. So the last term of the given AP is -100. What will be the preceding term? We have to add 2. So -100 plus 2. That is -98. What will be the preceding term? -98 plus 2. That is -96, and so on. So when we write the series in the reverse order, the first term would be -100. The next term will be -98, then -96, and so on. The first term of the given AP will become the last term of this series. Now the first term is -100 and the common difference is 2. We have to find the 12th term now. Since we have written the series in the reverse order, we have to find T12. What is T12? A plus n minus 1 D. That is -100 plus 11 into D. 12, so 11. 11 into D. What is D? 2. So -100 plus 22. That gives us -78. So the problem is done by writing the series in the reverse order and finding the 12th term. This can also be done in a different way. Let us find the number of terms of the given series. N equal to last term minus first term divided by common difference plus 1. Last term is -100 minus first term is -2 whole divided by common difference is -2 for the given series plus 1. So it is -100 plus 2 divided by -2 plus 1. That is -98 by -2 plus 1. That is 49 plus 1. That gives you 50. So there are 50 terms. There are 50 terms. We want to find the 12th term from the last term. You have to find the 12th term from the last. So we have to leave out 11 terms on the right. So the required term is T39. There are 50 terms. We have to leave out 11 terms. Why should we leave out 11 terms? Because we want the 12th term from the end. So 50 minus 11 is 39. So it is enough if you find T39 for the given AP. T39, that is A plus n minus 1D. A is -2 plus 39. So 38 into D is -2. So -2 minus 76. That's equal to -78. So even without writing the series in the reverse order, we can find the 12th term from the last. But the first method is a little easier. So that finishes the problem. Unit exercise 2. Sum number 7. Two APs, two arithmetic progressions, have the same common difference. The first term of one AP is 2 and that of the other is 7. first AP, first term is 2. For the second AP, the first term is 7. The common difference is the same for both the APs. Show that the difference between the 10th terms is the same as the difference between the 21st terms, which is the same as the difference between any two corresponding terms. Now, one AP, 2, 2 plus D, 2 plus 2D, and so on. Another AP, 7, 7 plus D, 7 plus 2D, and so on. For the first AP, the first term is 2. For the second AP, the first term is 7. But the common difference is the same D for both the APs. Let us take the first AP as capital T and second AP as small t. So let us find T10, that is 10th term of the first AP, minus T10, that is 10th term of the second AP. That is equal to 2 plus 9D, 10th term of the first AP. There the first term is 2. So 2 plus 9D minus T10, small t10. So A plus n minus 1D, here A is 7. So 7 plus 9D. Simplify. 2 plus 9D minus 7 minus 9D. That is minus 5. So we have got the difference between the 10th terms of the two APs as minus 5. Let us also find T21, capital T21 minus small t21. T21, capital T21 is 2 plus 20D minus small t21 is 7 plus, because the first term is 7 here, first term 2 here, 7 plus 20D. So 2 plus 20D minus 7 minus 20D. 20D at the minus 20D they get cancelled. So 2 minus 7 is again minus 5. So we find capital T10 minus small t10 is the same as capital T21 minus small t21. Not only that, difference between any two corresponding terms, 7 minus 2, 7 minus 2 or 2 minus 7, because we are finding capital T minus small t. So we have to subtract this way. Here capital T minus small t. Here capital T minus small t. Here also we should do that way. 2 minus 7, that is minus 5. 2 plus D minus of 7 plus D, that also minus 5. 2 plus 2D minus of 7 plus 2D, that's also minus 5. So difference between any two corresponding terms is also minus 5. Equation 1, equation 2, equation 3 shows the required result. That is what we expected to prove has been proved. Unit exercise 2, sum number 8. A man saved 16,500 rupees in 10 years. In 10 years, a man saved 16,500 rupees. In each year, after the first, he saved 100 rupees more than what he did in the preceding year. How much did he save in the first year? So, in 10 years, he has saved 16,500 rupees. So, yes, 10 is 16,500 and D is 100, because in each year, after the first year, he saved 100 rupees more than what he did in the preceding year. So, D equal to 100. We have to find A. That is, we have to find how much he saved in the first year. We have to find the first term. Given yes, 10 equal to 16,500. For yes 10, we can write the formula. N by 2, that is 10 by 2 into 2A plus minus 1, 10 minus 1, that is 9, into d, d is 100. And that is given to be equal to 16,500. So we have got an equation involving a only. So we can find out the value of a. 10 by 2, 5 into 2a plus 900 equal to 16,500. Both sides we can divide by 5. So 2a plus 900 is equal to 3,300. Now we can divide throughout by 2. So a plus 450 equal to 1650. That is a equal to 1650 minus 450. That is 1000. That is 1200 rupees. So we have got the value of a. What does it mean? He saved 1200 rupees in the first year. There the problem ends. Unit exercise 2, sum number 9. Find the GP in which the second term is root 6 and the sixth term is 9 root 6. We have to find the GP. To find the GP, we have to find the first term and common ratio. Then we can write down the GP. T2 equal to root 6. That is, second term is root 6. What is the general GP? A, AR, AR squared and so on. AR to the power of n minus 1 is the nth term, general term. Now, T2 equal to root 6. That is AR, AR squared and so on. So, second term, AR is root 6. T6 is 9 root 6. That is AR power 5. 2, so 1, 6, so 5. AR power 5 is 9 root 6 given. Equation 1, equation 2. Let us divide equation 2 by equation 1. Divide left hand side, divide right hand side. So AR power 5 divided by AR. We have divided the left hand side is equal to, divide right hand side, 9 root 6 divided by root 6. Why should we divide? If we divide, that a will get cancelled. We will get an equation involving r only. A get cancelled. R power 5 by r is r power 4. 5 minus 1, that is r power 4 is equal to 9. R power 4 equal to 9 means r equal to 9 to the power of 1 by 4. 9 to the power of 1 by 4. That 9 can be written as 3 square. So 3 square whole power 1 by 4. That is 3 to the power of 1 by 2. 2 into 1 by 4 is 1 by 2. 3 to the power of 1 by 2 is nothing but root 3. So we have found out the common ratio r as root 3. Now using this value r equal to root 3 in equation 1, we can use either in equation 1 or in equation 2. Equation 1 is relatively simpler, so we use in equation 1. Using in 1, a root 3, AR equal to root 6, so a into, so a root 3, r is root 3, is equal to root 6. So a equal to root 6 by root 3. We can put under a single radical. Root 6 by root 3 is root 6 by 3. That is root 2. So we have got a, we have got r. So the GP can be written down. A, AR, AR squared and so on. A root 2. AR root 2 into root 3. AR squared root 3 into root 3 square. We can simplify. Root 2. Root 2 into root 3 is root 6. And root 3 square is 3. Root 3 into root 3, 3. So it is 3 root 2. So the final GP is root 2, root 6, 3 root 2 and so on. So we have finished the sum. Unit exercise 2. Sum number 10. the value of a motorcycle depreciates at the rate of 15% per year. It depreciates, that is decreases. What will be the value of the motorcycle 3 years hence? 3 years hence, that is after 3 years, which is now purchased for 45,000 rupees. Now let us start. If X is decreased by R%, that is if X is depreciated by R%, the GP is X, X into 1 minus R by 100, X into 1 minus R by 100 whole square, and so on. If it is appreciation, then we have plus here. Now it is decreasing, depreciation, so we have minus. So what is the GP for depreciation? X, X into 1 minus R by 100, X into 1 minus R by 100 whole square, and so on. After 1 year, this is the value, X into 1 minus R by 100. After 2 years, this is the value, that is X into 1 minus R by 100 whole square. So the value of the motorcycle after 3 years, that is 3 years hence, is X into 1 minus R by 100 whole cube. After 2 years, after 1 year means 1, after 2 years means 2, after 5 years means X into 1 minus R by 100 whole power 5. Now we want to find the value of the motorcycle after 3 years, that is 3 years hence. So X into 1 minus R by 100 whole power 3. Here X is 45,000 rupees given in the problem, and depreciation percentage 15%. So 45,000 into 1 minus 15 by 100 whole cube, that is 45,000 into, take LCM, 100 minus 15 by 100 whole cube, that is 45,000 into 85 by 100 whole cube, that is 45,000 into 17 by 20 whole cube. Now we can calculate this, getting 27,635 and 63 paise. 27,635 rupees and 63 paise. That is 27,636 approximately. So that is the final answer.